Students, now let's see two more standard formulas. We have y is equal to k raised to x into sin bx plus c, and y is equal to k raised to x into cos bx plus c. So we are going to see both the derivations simultaneously. Now for these derivations, I will need the standard forms y is equal to e raised to ax into sin bx plus c, and y is equal to e raised to ax into cos bx plus c. So let's write the two standard formulas first of all. So we remember, if I have the function y is equal to e raised to ax into sin bx plus c, then students, yn is given by what formula? Yn becomes equal to r raised to n into e raised to ax into sine of bx plus c plus n times of phi, isn't it? So this is one of the derivations. And then the other derivation was for y is equal to e raised to ax into cos of bx plus c. Here we remember that yn is again given by r raised to n e raised to ax into cos of bx plus c plus n phi. Now for both these standard formulas, for both of the derivations, the value of r and phi was same. What was r? R was root of a square plus b square, and what was phi? It was tan inverse of b upon a. So you remember these two standard formulas or the derivations that we have learned. Now I'm going to make use of these two formulas to get the standard formulas. Y is equal to k raised to x into sin bx plus c and k raised to x into cos bx plus c. So let's begin with the very first one. So the first one is y is equal to k raised to x into sin bx plus c. Now observe carefully how I'm going to proceed with this particular standard function. I'm going to transform this standard formula into y is equal to e raised to ax into sin bx plus c. Once I transform this particular function k raised to x into sin bx plus c into this function e raised to ax into sin bx plus c, the derivation will be exactly similar to what we have learned previously for this one. It is going to be exact same. At the end, you will just do some replacements. So whatever derivation you have learned for this one, you have to exactly copy word to word for this function as well. Y is equal to k raised to x into sin bx plus c. But before you proceed further, you need to change k raised to x to e raised to ax. So let's see how this can be done. Observe carefully. So I'm going to show you only those steps which are required to transform this function into that function. Once you get that function, exactly similar derivation will be written for that one also as we have written for the previous standard formula. So you just have to copy it word to word. So observe carefully how I'm going to transform this. Now, do you know that e raised to log x, if I have log x to the base e raised to, I have a function of log x, and this log x also has the same base e as the base of the entire index over here, the entire e raised to log of x to the base e. This particular exponential term has the base e, log x also has the base e. So this, if you remember, comes out to be x. If the base of the entire exponential term and the base of the logarithmic term is same, you get the same x over here. So I can extend this to e raised to log of, instead of x, if I have a function of x, base has to be same. So e raised to log of f of x to the base e, it is again going to become simply f of x. Now I have already told you that you should be able to read the formulas from both the sides. It goes from left to right. It also goes from right to left. So if I ask you what is the value of f of x, can you write f of x as e raised to log of f of x to the base e? Isn't it? So this is a very important formula you should be memorizing. So now observe carefully. Look at this k raised to x. Observe carefully, students, now. So this was just a formula. This might not be the part of the derivation. It's just a formula that you should be knowing. So observe carefully. Consider k raised to x. Now this k raised to x is f of x for me. K raised to x is f of x for me. It can be written as e raised to log of f of x, which is k raised to x to the base e. E raised to log of k raised to x to the base e. This becomes equal to, now don't you know that log of a raised to m is m into log a. So log of k raised to x can be written as x log k. So e raised to x log of k, obviously to the base e. Now what is k? K is a constant. K is a constant. If k is a constant, what can you say about log k? Therefore log of k to the base e is also a constant, isn't it? Log of k to the base e is also a constant. So if log of k is a constant, can I call it as a constant a? So let us say log of k to the base e is taken as a. So this becomes e raised to ax. So k raised to x has transformed into what? E raised to ax. This is the exact same thing you will be writing for the other function if you start y is equal to k raised to x into cos bx plus c. Nothing is going to change if this becomes cos bx plus c. All these lines will be exactly copied for the other derivation also. So let's go back to y now. Therefore what does y become equal to? Therefore y becomes equal to this k raised to x. K raised to x has transformed into e raised to ax into sine of bx plus c. Now you know what has to be done further, isn't it? This is y equal to e raised to ax into sine of bx plus c. You need to exactly write the entire derivation one more time for this particular function as well. So therefore I can say yn is going to be, I'm not going to derive it one more time, isn't it? You just have to know that the derivation is going to come over here. So yn is going to become what? It is going to become r raised to n e raised to x sine of bx plus c into bx plus c plus n phi, isn't it? You have yn is equal to r raised to n e raised to ax sine of bx plus c plus n phi. What is r here? Where r is going to be root of a square plus b square and phi is going to be tan inverse of b upon a. So I now need to transform this e raised to ax back into my original question. And what was my original question? It was k raised to x into sine of bx plus c. So therefore I can say y becomes equal to, what is e raised to ax? I simply know that e raised to ax is k raised to x. K raised to x was itself written as e raised to ax, so it will again go back to k raised to x. So e raised to ax is k raised to x. Nothing changes in sine of bx plus c, isn't it? So therefore yn becomes equal to r raised to n into k raised to x, because e raised to ax is k raised to x, into sine of bx plus c plus n phi, where what is r going to be? It is going to be root of a square plus b square. So students, tell me what is a here. If you remember, I had k raised to x as e raised to ax. Observe carefully. What is a? If you see, a is log k. So when e raised to ax transforms into k raised to x, a will also transform into log of k. So here r, it was root of a square plus b square. But what is a that you have now? It is log of k. So I write here log of k the whole square. It has a base e. Now remember, log of k the whole square is not going to become 2 log k. It will remain log of k the whole square. Plus, of course, you have b square. So you write plus b square, isn't it? So that's value of r, and phi is going to be tan inverse of b upon a, isn't it? Tan inverse of b upon a. So what is b here? B is going to become b itself. So b, I'll write b as it is upon a. Students, what is the value of a again? A is log of k. So you get b upon log of k to the base e. So this is the nth derivative for y is equal to k raised to x into sine of bx plus c. Now students, once I've got a value of k raised to x into sine bx plus c, can you suggest me for y is equal to k raised to x into cos of bx plus c? What is the yn going to be here? So yn is simply now going to be again r raised to n k raised to x cos of bx plus c plus n phi, where what is r going to be, students? It is going to be root of a square plus b square, but I know a is going to be log of k, so I get here log of k to the base e the whole square plus b square, and phi is going to be tan inverse of b upon a, but I remember the value of a is log of k, so b upon log of k to the base e. So that's your formula, the standard formula for y is equal to k raised to x into cos of bx plus c. So students, here what have you learned? You have learned the standard formulas, the derivations for y is equal to k raised to x into sine bx plus c and k raised to x into cos bx plus c. What I did in the derivation was I simply changed k raised to x into e raised to ax using the formula of logarithms. So that is the only new thing that you have learned in this particular derivation. The rest of the derivation is exactly same as the previous two derivations. So I hope you have understood this particular derivation. Now let's proceed ahead, students.